In 3.5, we are now going to transition away from the proofs just a little bit. In 3.5, there are going to be a lot more problems that you are going to need to use a calculator on. There's going to be a lot of adding and subtracting to 180 and figuring out what missing pieces are, possibly even dividing by 2 when you're dealing with these problems. The primary things that you're going to be dealing with are problems that deal with isosceles triangles, and I think there's only 1 or 2 equilateral triangle problems. So our major idea will be isosceles triangles, and the hardest part about worksheet 5 is they're going to do things that are going to try to confuse you. They are going to try, the person who wrote this worksheet deliberately drew the pictures to try to deceive you as to what is congruent. They're going to make it look like all 3 sides are the same when only 2 sides are going to be the same mathematically. We're going to have to figure out what's the same or what is congruent using mathematics, not by what it looks like. That's what I basically mean. So what we need to do is we need to use the angles or side lengths to know what is congruent. I'm going to show you how to do that in just a moment. Then use arcs or congruent marks. The last thing that I need to tell you before we get into the 2 properties are that the sum of the angles of a triangle add to 180. We've done that before, but we're going to use that a lot in this section. So the major idea is that in isosceles triangles, 2 sides are the same. If 2 sides are congruent, then the opposite angles are also congruent. If the opposite angles are congruent, then 2 sides across from them are congruent. That's our big idea. I want to draw you a quick picture. And I'm going to draw you a picture that is a triangle. This worksheet is going to draw a triangle, and it's going to look like all 3 sides are the same. But what they'll do is they're going to do something like this, where they're going to say, this is 21, this is 20, and this is 21. And they're going to give you some numbers, like this is 21 feet or inches, and this is 21 inches, and this is 20 inches as well. This is an isosceles triangle. 2 sides are equal to each other. If 2 sides are equal to each other, then 2 angles are going to have to be equal to each other. And if you want to know which ones are equal to each other, it's the ones that are opposite or across from the sides that are congruent. Meaning, if you see that this one is the same as this one, you could easily just draw like a little arrow in your mind, and draw a little arrow in your mind to the angle that is across from it, because if 2 sides are the same, then the 2 angles across from them have to be the same. That's your major property. That's your one concept that they're going to use over and over and over again on this worksheet. The 2 sides that are the same, the 2 angles across from them are also the same. And then I wrote that the converse is also true. Meaning, if I have a triangle and I have a 50-degree angle and a 50-degree angle, and I have 2 angles that are the same, I can put an arc and an arc on these 2 things, because 50 and 50 are the same degree measurements. Then I know which 2 sides are the same. This one over here has to be the same as this one over there. They have to be, because they're across from those angles that are the same. And so that's how you're going to do a lot of the problems. They're going to throw in some X's and Y's and see if you can figure it out using these principles. If we understand this, we should be able to do all the problems that are below. The last thing, remember I told you there was either 1 or 2 problems that dealt with equilateral triangles. Well, if all 3 sides are the same, then all 3 angles must be the same. And if all 3 angles must be the same, then that means all 3 angles must be 60 degrees each. It's the only way for that to exist. So now I have some examples for you. I've chosen numbers 1, 2, 9, and 16. 1, 2, 9, and 16 to do together. If you have your worksheet, feel free to pull that out. You can do this on worksheet 5 if you would like. Our directions say for number 1, solve for x. Show your work. Note diagrams are not to scale. What does that mean, not to scale? It means that if you were to take and measure that this was a 5, then if this may look like it, but it's not going to be drawn necessarily accurately. Don't bank on what it looks like. That's what that means, okay? So here's what they're asking us. What is this angle's measurement here? It is not 26 degrees. So what you're going to have to do is you go, oh, I see that 5 and 5 are the same. These two sides are the same. I usually put 2 congruent marks just like that. 5 and 5, those are the same. 3 is different. It's not equilateral, it must be isosceles. If these two sides are the same, then 2 angles must be the same. This angle here that's across from that side must be the same as this angle here, which is across from that one. These are called the base angles. So you don't need to know that, but I'm going to say it anyways just for good measure. The base angles have to be the same. If this is x, then this has to be x. And as soon as you know that, now you have enough information to figure out what x is. This plus this plus this, all 3 of these add up to something you should already know. So all you have is x plus another x plus 26 equals 180. 1x plus another x is 2x plus 26 is 180. I can subtract 26 from 180. I'm thinking that is 154. Tell me if I'm wrong. And then since 2 times something is equal to 154, we just divide it by 2. And this is why I told you a calculator would come in handy. If you don't have a calculator, you can borrow one from me. I'm going to pull mine out. 154 divided by 2, just because it'll be easier with the calculator. X is 77 degrees. I always check, is that what they asked for? They said solve for x. I found what they were asking for. And if I wanted to, I can check. 77 plus 77 is 154, plus the 26 adds up to 180. It should make sense to you. Let's scroll to number 2. Number 2, they have a 10, a 15, and a 15. They have an x degrees and a 75. What they're trying to do is they're trying to make you think that the 2 angles that are the same are the x and the 75. Sometimes it will be, sometimes it won't. You have to decide based off of, oh, 15 is the same as 15. It's isosceles. If the 2 sides are the same, the angles across from them are the same. This angle here has to be the same as this angle there. That means if this is 75, this other angle, the base angle, which is on the left side this time, must be 75 degrees. Has to be. Arc, arc. And now you have enough information to figure out what x is. A lot of you, some of you can do this in your head, but most of you, if you get stuck on this, just write 75 plus x equals 180. And then you'll know 75 plus 75 is 150. You could do that on a calculator if you need to. And you could subtract 150 from both sides. And you can figure out what x is equal to, which is 30 degrees. Since almost all of these problems deal with isosceles triangles, that's the process. Sometimes they're going to be equal to each other. Sometimes they're going to add to 180. You need to figure out which sides are the same. And then what they do is they're going to amp things up a little bit. They put a 41, a 42, a 3x minus 1, a 62, and a 56. This is a solid Math 2 problem right here. It's not the easy stuff. It's right in the middle. This is not the hard stuff. It's just a nice medium level problem. Because it's really hard to look at this and to tell which two sides are the same, because this triangle, if you look at it, looks equilateral. But it's not, based off of these numbers. So which two sides are the same? It's hard to say until you figure out what this angle is right there. If I figure out what that angle is, then I might know what the two sides are. So what I'm going to do is I'm going to say 56 plus 62. I'm going to figure out what that is. That's 118 degrees. And I know that those two plus this one should add up to 180. I'm going to call that plus x equals 180. So I can figure out what that has to be. I'm going to subtract 118 from 180 to get that angle here has to be 62 degrees. Let me put it this, let me erase that real quick. Now if that's 62 degrees, and we mathematically figured it out, now you see two angles, hopefully, that are the same. 62, 62, two angles are the same. If two angles are the same, it's isosceles. If two angles are the same, two sides are the same. Which two sides? The ones across have to be the same as each other. I usually just draw these little arrows. And now you know that the 3x minus 1 isn't equal to that one, it's equal to that one. It has to be. And now we could set up, I probably should have called this a y. Now that I think about it, I'm going to call this a y. That way I don't get it confused with my x. Now that this side's the same as this side, I'm going to set 42 equal to the 3x minus 1, because those are the two sides that have to be the same. And once we solve this, we're done. 43 equals 3x. Oh no, divide by 3. And I'm going to check, but I'm pretty sure 3 does not go into 43. I'm going to check on my calculator. When I did 43 divided by 3, if it stays like that, just leave that as your answer. If it does not go in, just write x is 43 over 3. That's why we taught you fractions. So you can give us answers as a fractions, as long as they're in lowest terms. And our calculators, the ones I recommended, always put them in lowest terms anyways. Any questions on 9? My last example is number 16. Number 16 asks us to do several things. The directions are up here at the top. And it says to solve for x, find the perimeter, classify the triangle, and show your work. Okay? So let's go ahead and look at 16 before we get started. I have an 8x minus 44 degrees is this angle. I have a 3x plus 21 degrees is that angle. I have a 5x minus 5 degrees as this angle. I think the first thing I would do is I would go, okay, this angle here has to be the same as this angle there because they are, vertical angles. So I would actually go and put a 5x minus 5 right there inside. It's in parentheses because it's a group. It's the whole thing. So these are the same by vertical angles. And now I have this angle plus this angle plus this angle. I have all three angles, and I know that they add up to 180 degrees. So what I'd probably do is I'd probably set up something like 8x minus 44 plus a 3x plus 21 plus a 5x minus 5 should all add up to something that's equal to 180 degrees. I usually line them up like that. That way I can put my x's together. 8, 9, 10, 11, 16x is what I'm getting there. Now I'll put my numbers together, the negative 44, the 21, and the negative 5. And I'm just going to do that on the calculator. 21 minus 44 minus 5. I'm getting negative 28. Just a reminder, since I do like to show you things on calculators, if you have a negative 44, don't forget there are negative buttons on calculators. They're the ones in parentheses. Subtraction means something different on a calculator. So if I press that negative button that I'm pointing at right there, that'll give me a negative. I can do negative 44 plus 21 minus 5. And calculators with negative buttons can still give you answers that are negative. It knows how to do negatives and positives. If you need that, use it. Don't be afraid to. Okay? I'm going to add 28. I think that's 208. I'm going to divide by 16. 208 divided by 16. Oh, it goes in nice and even. 13. So my first set of directions says solve for x. I have answered the first part of the question. The second part of the question says find the perimeter, but that's for 14 and 15 for whatever reason. 14 and 15, we're finding perimeter. I can't find the perimeter of number 16 because I don't know what this side is or this side or this side. But the third thing it says is classify the triangle. Because x is 13, it is going to ask me to classify the triangle. I don't know what this triangle is until I plug in the x and find out how big those angles are. So for example, if I take the 13 and plug it in here, and I take the 13 and plug it in there, and I take the 13 and plug it in there, that'll give me a clue as to what kind of triangle it is. Let's figure out what 3 times 13 plus 21 is. Let me do that. 3 times 13 plus 21 on my calculator. That means that this angle is 60 degrees. And I can plug that 13 in up here. 8 times 13 minus 44. 8 times 13 minus 44. Do that on my calculator, and guess what? That is 60 degrees. Which means the last angle that I plug in, 5 times 13 minus 5, 5 times 13 minus 5 is 60 degrees. That's what's going to let you know what kind of triangle it is. How many angles are the same? 3. What does that mean when 3 angles are the same? It means the 3 sides are the same. What kind of triangle is that? Equilateral. Equal sides, in other words. I'm going to stop your notes right there.